A little while ago, one of the local farmers came into my workshop in a bit of a flap, and he gave me this part. Not this part exactly. It was new old stock. It's a bushing from a New Holland hay baler. Basically, it's an older bit of gear, and New Holland isn't making those parts anymore. It's not supported. And those parts were super, super old, and basically you could snap them in your fingers. They were no good. I imagine he paid a pretty penny for those, and now he was just sort of high and dry. His main business is making hay, and so anyway, he brought me the broken part and was like, can you make this? Can you make it out of steel? He obviously wanted something that would last. And I was like, I think I could do one better. And I brought him into this space, and this is my little work office and 3D printing area. And I was like, how about I 3D print this for you? And he obviously knew what a 3D printer was, but had never seen one, and he was quite fascinated. So I went to work drawing this. I basically had to just work it all out by trial and error. And eventually I got there, and we have this part. And thankfully it worked. In fact, he was super happy. And, this costs me, a couple of bucks to print. A lot cheaper than it did for him to buy. This is easy for me to make. The cost was my time to sit there and draw it. Now, this is where, had I had something like this little guy here, this is the Ferret Pro, and had I had something like this could have really been a labor-saving device, and it would have got the price down even lower, because I would have just had to have, all I would have had to have done was scan this, and I would have been off to the races. It looks like a dog's breakfast now, but when this is done, we should be able to hit render, and we should see a nice complete model. That doesn't look like much, but that's actually really cool. Alright, let's stop that. Complete scanning. Yes!
Success.
I was looking at this before and thought, didn't even get that round. And in closer inspection on the actual part, they're actually not round. So that's pretty cool. We've got the flat on the shaft. This is a scanner designed for like something no smaller than 150 millimeters by 150 millimeters. So that's 15 millimeters square. This is a little bit smaller than that, so I know I'm pushing the friendship. That's pretty cool. Taping up those wires, I think, really helped the situation out, and removing the spray from the top half and just putting it on the shiny sections on the motor. Parts in fusion, and it's a bit it kind of looks like the part went through a house fire, but I think we have some useful geometry here that I can use. Yeah. This was a good learning exercise, just seeing what it's capable of, pushing the boundaries a bit for this particular scanner. And I'm really happy with how it turned out. It was it helped a lot as far as confidence was concerned, and that this part was going to work the first time. Because I've done this a few times well, not this, but it's really easy to overlook a detail and then have a part not work. And so having this motor and gearbox physically in the computer, it sort of guaranteed that I wasn't going to screw it up. For me, the next step is to turn this plastic part into aluminium. I want to cast it, and I'm going to use the lost PLA method, except this isn't PLA, it's PEGT, but I purposefully printed it really thin. The infill is like 5%, and I'm hoping that'll work. Now, in preparation for castings, looks like I've got a black eye. I don't, I've just been handling charcoal and I've obviously rubbed my eye. Not a good look. So, in preparation for doing this casting, I decided to break out the old wood-powered foundry. Now, the only problem with it was it wasn't really wood-powered, it was palm nut powered. But that was because the fan that I was using, the vacuum cleaner, just had too much oomph and it would blow the wood out. Now, I've recently, anyone who's been following the channel for a while knows that I've recently gotten into blacksmithing, and I bought a proper blacksmithing blower from China for a reasonable amount, like $30, and I've hooked it up. So there it is. That's currently running just on 2 pieces of pine, pallet pine. I'm pretty happy with that. I'm like genuinely stoked. And listen to it. It's quiet. Have you ever heard a forge, like even the gas powered ones that run this quiet? Like, this is what I was going for, and it's great to finally get there. And now that I'm using it, this is just a test run, there's a lot of things I want to fix. Like, this is another cool thing, is I'm able to tune it with the speed controller, something that I just couldn't do with a vacuum cleaner. So the things that I need to change is the how I refuel it. There's no handle on it, and the hole that was in the lid, which was necessary to let off excess pressure from a vacuum cleaner, it's not needed anymore. In fact, I could do with a really good tight sealing lid now on the hopper. I would say that would melt aluminium. Oh, yeah. There's that. This is Rusty the Roo, and Rusty the Roo is going to be in another video where I'm sort of checking out this welder from Arc Captain. Now, I didn't make Rusty. Rusty was made by a couple of friends who are some local artists, and I've been teaching them how to weld. And this is actually the very first thing that they've ever made, and it's pretty damn good. Yeah, seriously impressive for someone, for an older couple who have never done this sort of thing. And it was the wife that did most of the welding, and I just think, Wendy, you did a fantastic job, and so did you, Rob. Like, you guys are killing it. It being their first time welding, they sort of it needed a little bit of fixing up. It's not really a criticism, it is what it is. And they've graciously allowed me to just do those repairs, because I'll just be a little bit quicker to just get it all done. So they're perfectly capable of doing the repairs themselves. They just need it done quickly, because it's going out to a zoo along with its emu mate, which I don't have a picture of to show you, for public viewing, which is pretty cool. Anyway, just keep going. So I've repaired this 3D print with a little bit of wax. I basically printed this as thin as I dare. Like, whatever the minimum settings were for infill and the outer shell thickness and layer and everything else, I just went minimum, and as a result, this is really quite fragile. And because I was printing it on a Bowden style extruder and not a standard print head like what's on my other printers, and I just failed to switch those settings around, there was an incredible amount of stringing, and in the process of cleaning that up, it just got a little bit damaged. No big deal. I don't want to spend a lot of time on this first one. This is kind of like the test run, and you know, I highly doubt that I'm going to get this right the first time, so this is just the learning process. And this print is far from perfect. Whatever the opposite of perfect is, that's what this print is. But I'm going to cast it in this piece of steel pipe, and I'm going to probably put it in upside down like that, and fill it backwards, because I'm not going to try and, you know, do the whole split half mold traditional casting method. This is going to be the lost foam, lost PLA method. Basically, you just bury this thing, and hopefully, if your aluminium's hot enough as you tip it in, all this plastic, which is corn based, it's PLA, so it's basically cornstarch with a bit of colouring, that'll just evaporate and leave behind a part that resembles this. That's the plan anyway. But to begin with, because we've got some really small features, I'm just going to mix some of this sand, which has come straight from my garage floor. It's just really nice. I'm going to mix some with glass water with that and just fill these holes, just to make sure that that happens, because I can't really tamp this down hard. I will just destroy this if I do. So I'm just going to pack the more sensitive areas, and then we'll just fill around it, and let's just see what happens. If all else fails, I do have a much nicer printed version. This is the same printer but with the correct settings, and as you can see, night and day. The only problem is I tried to get a bit fancy, and I hollowed out some of these risers, and obviously they were too thin, and the slicing program just missed them altogether. So I have features here that just aren't there. So I ended up just stopping the print halfway through, as I figured I could just glue some foam to this, or, you know, if I'm going to use this, I'll repair it for that purpose. But for now, I just wanted to show you that that printer could do really nice work when you have the right settings. Very nice work, in fact. That print is the Creality Ender 3 version 2 Neo. What a mouthful. Never had a Creality printer until now. I went out and bought that with my own moolah, by the way. Secondhand. Okay, backstory for that printer. So the parents bought it for the teenager, just to give him something to do. And the teenager just was a bit of a know-it-all, and though his parents really tried to help him to get it set up right, he was just like, no, I know what I'm doing. And when I got it, the print bed was like crazy unlevel. The offset from the nozzle was like 10 mil off there's just no way it would have worked. And he hadn't assembled it properly. He didn't know what an eccentric cam was. I couldn't blame him. But anyway, once I tightened everything up, leveled the bed properly, it just worked beautiful. Anyway, stop talking. I need a face shield, so a welding helmet on grinding mode is my best option. I'm getting close. I'm not sure how I'm going to capture all this on film. I need to move kind of quickly so that I don't lose too much heat with the aluminium, though I probably don't need to rush either. Yeah. I don't know what I was expecting, but it wasn't really that, but hey, we'll just let that cool. Yeah.
Oh.
We didn't quite melt through all the plastic. Okay.
Okay.
Man, that glass water sets hard. There's still melted plastic on it, which I would have thought that would have for sure would have consumed it. But I mean, that hole is there. Let's cool this thing off. Those holes were there. This hole is there.
So it's meant to look like this?
Yes, it's meant to look like that.
Okay.
Instead it looks like, it actually looks...
like a Roman Colosseum.
Yeah, after Pompeii.
Yeah.
Yeah, definitely a... Oh, okay, we got another feature there. Just... There we go. These gates obviously weren't big enough because we didn't fill in far enough, and I think everything rushing down sort of made it into the middle and then sort of trapped the plastic. So everybody else on the internet makes a mold like this out, and they use glass water for the whole thing, and then before they pour it, they put the whole thing in an oven and burn the plastic out. And I guess I should have done the same thing. Though I do wish that one of these people that, you know, create these slicing programs would have a function so when you 3D print something it would make it as thin and as minimalistic as possible for the purpose of casting. That would be really cool if someone out there could do that. I can't do that, but it's just a thought I had while I was doing this. Have like a casting mode for printing where it basically just gives you a really thin shell with very minimal structures in the middle, just enough to support it. Anyway, yeah, that's hot.
Like a silver rock.
Well, the good thing about this is I can just break that up and try again. So, it's actually a functional part. It looks like a fish tank ornament. Lots of sand inclusion, and obviously the plastic sort of got in the way. And maybe I probably wasn't hot enough. But yeah, the bolt holes are all there. They do seem to be on dimension somehow. And we have at least 1, 2, 3, 4, 5 points of contact underneath, so, you know. Yeah, I'm going to call that a success. No, not really. But unfortunately, this is all the time I have for this, and I do want to come back to it. But I just need to do a bit more research, I think. Because, yeah, no sense in me working this out the hard way when other people out there have already worked it out. So, well, thank you very much for watching. Thank you to Creality for sending me the scanner. I really do. I really appreciate that, and I like it. It's pretty cool. There's been a lot of jobs in the past where I wish I had one. It would have made it so much easier, and now I do. So you'll probably see this thing get used as needed. But otherwise, I feel like that's it for this video. Thank you for watching, guys, and I'll catch you in the next one.